Alright, this is the third assignment, third hand in for procedural programming. This assignment we needed to build a slideshow with 10 pictures with at least one transition, and I'll just show you the slideshow to begin with. Yeah. This is the half. It takes the top half off and then the bottom half off. And this one will be a color fade, gradual color fade. And after this there will be a fade to black and then a fade back to the next picture. And after this one there will be an alpha blending, and it will continue to loop through the pictures. I'm apologizing because I'm a bit ill, and that's why I sound a bit snotted. Right, that's the first picture again. As you notice in the on the output, we have the output of the alpha value, the output of the art, which is the value of the art, which is used to afterwards choose the type of transition. And here is the value of the counter, which is used also for the transitions. And I'm basically using this as a debugging tool, so I can see where the problems are and what is happening. Alright. I'll start off with the main file. Here I'm setting the window size of the slideshow to the size of the pictures as a default when it pops up. Here we have the test app header file. This is where I'm declaring the pictures, and I am also declaring some variables. I have the alpha variable, the art variable, the color choice variable, and the counter variable. Here I'm declaring the array of the images, and also a char of the data, which I'll later explain. We have the texture, and here we have the test app class. And here, to begin with, I'm loading the images into the variables. I have the data, and here I'm assigning the data to the size, the resolution of the screen times 3, and that is because the data will be served as a line, and in that line we will have not only the different points in the screen, but we'll have them in all three colors, so we need to multiply them by 3. And here I have here I'm entering the different images into the array. I am declaring the values of the different variables: art, color choice, and counter. And I also have the the texture, which is set to the size of the screen and to the color, which is RGB, red, green, and blue. Yeah, and in the update function, first of all, I am declaring the amount of pixels. Of course, the amount of pixels that, as in the data file, also times the resolution times 3, it's because of the different colors. Here is my debug line, where I'm couting the alpha, the art, and the counter values. I have a background which is red, even though you can't see it unless you of course open the window to be larger. To start off with, the first transition, this is the simple alpha blending. What I've done is I've taken the art value and I've created a modulus of 4, and that way the art number can continue infinitely, but we always have a modulus of 4, and that's that way I can keep it in between the 4 different transitions. So if it's with 0, or if art is equal to 0, and I did that because, as in modulus, 0 is it cannot be calculated. And start off with having a counter of alpha that sometimes it can be I actually I don't need this for in this case, but if I was using a float, I would have actually needed this. It's because sometimes it can start as a minus, and that way it will take longer to run, but I don't need this now. Oh, I'll delete it. And what it does here, it says if the alpha is lower than 1 or equal to 1, then it will run this loop. And what this loop is the alpha blending. It does the alpha blending. It takes the alpha value and it deletes it from the present image, and while it does that, it adds that value to the image that comes afterwards, and that way they are changing relatively. So the image that we are in goes down in alpha value, and the image that we are going to see goes up in alpha value. I didn't want to use a counter here. I want to use something more simple. So even though this will only run until alpha is equal to 1, the alpha will continue to rise until it is equal to 9.95. And when it does that, it will run the next image. Yes, and here's the next transition. This is the half, if I'm correct. Yes. And what this does is it again, the modulus 4 is equal to 1. All the pictures that are modulus 4 equal to 1. And what I have is a count here. The count goes always up by 1, increments by 1. And we have some if sentences for every time the counter hits a certain number. So if the counter hits 75, then what it will do, it takes the amount of pixels and it divides it by 2, and then it runs it only runs until half the amount of pixels, so it only grow halfway. And if the counter is 125, I've done that it will continue from halfway until it reaches total. And then when it reaches 250, then it will finish and it will continue with the slideshow. Of course, resetting alpha to 0 and counter to 0. Now here's the third transition. Here I have a it's a gradient color alpha blending. It takes different, it's more like an RGB color blending. What it does is it takes one color at a time and alpha blends it. And the way I do that is I take, instead of the regular alpha blending, which I'll show you at the top, in the regular alpha blending it increments by 1 each time, and that way it goes through all the colors at once. But in this way we have color choice. Now color choice is the value that we use to choose which color we are going to change, and the alpha of that color. And what we do that is we take the instead of incrementing by 1 each time, we can increment it by 3, and that way we'll be hitting the same color all the time, and that way we'll also only alpha blend that color. Of course, once we reach 0.95, we will increment the color choice by 1, and that way instead of it starting b equals 0, it'll start b equals 1, and that will mean that it will increment by 3 from 1. And the same again, once it hits 2, it will increment by 3 from 2, and that way it will hit all 3 of the different colors. Once I've said at once that the counter is equal to 200 and the color choice is higher than 2, then it will change picture and of course reset the counter to 0. Yes, and here we have the fourth transition. The fourth transition is a fade out, fade in transition. Here we have the counter again, an if sentence of the counter, that if it's between these values of the counter, then it will increment the alpha by 0.05 and run this function, which